Hello everyone. In this session, Computer Networks Lab program, we will discuss about the program 4. Write a program for error detecting code using CRC and CCITT. CRC is nothing but cyclic redundancy check and CCITT stands for Consultative Committee International Telephony and Telegraphy. Before the code, I just want to talk about the what you do in the sender side and receiver side. In sender side, we will have the data CRC bits and checksum. Initially, data should be transmitted. After data should be transmitted, CRC generator, let consider n bits in the CRC generator. Let us assume it is a key. Once CRC generator will be send the data, CRC bits, calculate the CRC bits. How do you calculate the CRC bits? CRC generator equals n bits, CRC bits equals n minus 1 bits. For example, n is equal to 5. How do you calculate CRC bits? N minus 1 bits. 5 minus 1 is nothing but 4. How do you calculate CRC bits remainder? CRC bits remainder equals data plus n minus 1 0 divided by CRC generator. Finally, we have to calculate the checksum. Checksum equals data plus CRC. I just send it to the sender. So sender side what will do? Checksum is there and it is divided into the CRC generator. The remainder will be 0. It may remainder is 0. What does it mean? My data doesn't have any error. If I get any remainder is non-zero, then you mean that there is some error in the data. Checksum in the receiver side. So let us see the code. Import java.uitil.star. This means imports utility classes that you have made use of input or output or data handling. The next step is public class CRC. This will be define a class named CRC. Inside, if you can implement CRC logic like encoding or checking. Void division. So here I am using int a and comma int k. This is a core division logic, performs modulo 2 division of the bit array a by the generator polynomial starting from the first k bits. K bits is the original message length to compute the remainder CRC. Int g, it is used to perform polynomial long division 0. Here I am using the inputs are A and K. A, the working array containing the message followed by 16 zeros. K is the original message length. After that I am using the loop. Loop overall each bit's position up to K. If the current bit is 1, it will be matches the generator polynomial 0. Next is start XOR. The next if 7 bits with the generator polynomial from here to here. This simulates polynomial subtraction. After that we have to enter into the main program flow. Creates array A of A and B to hold bits. Reads the message length and the message bits 0 or 1 from the user. Append 16 zeros for the CRC spares. Next we have to extend the message by 16 zeros to make for the CRC remainder. Here we have to look into the important K is equal to length minus 16 stores the original message length before zeros. Next we have to copy A into B to preserve the original message plus 0. After that we have to compute the CRC remainder. It will be calls the division function on A. Next one is object dot division A of K. This is after division the last 16 bits of a contain the CRC reminder. Next here also I am using the loop. For int I is equal to 0, I less than length, I plus plus. A of A is equal to A of I power B of I. This operation effectively places the reminder CRC into the last 16 bits of the frame while keeping the original message unchanged, producing the message plus CRC. Next we have to print the transmitted data. Receive and verify. Reads the received from the redivide the received frame by the same generator. The next one is object dot division A of K. This will be check the reminder. If any bit in A is non-zero after division, there is an error. Add system dot out print next line is no error to the else block. Once the program is done, next we have to last and final to run the program. To run the program, the output will be enter the length of the data frame, enter the message, data to be transmitted. So if error in data or no error in data depending on the